Hey, 1590, let's go over guided notes 3.4. I know I say this all the time, but I really like this section a lot. Okay, I love composition of functions. So I think they're really fun. But you have to understand what a function is. You have to, by this point in our game of math, know that this f is not a variable. It's the function given the variable x. And g is a function, not a variable. G is a function with variable x. With real number outputs, we define new functions. So we're going to create new functions. One will be f plus g. So the function f plus the function g. Another one is the function f minus the function g, function f times g, and function f divided by the function g. All right, so this is how we're going to do this. If you have f plus g, you're going to take the function x, the function f of x, and add it to the function g of x. All right, then the next one for f function f minus g, it's the function of x minus the function g of x. And then multiplication of the two functions, that's just the function f of x multiplied times the function g of x. And then last is the division, function f of x divided by the function g of x. All right, that just tells us what we're going to do, what we can do, okay? Let's go to example 1 where we're actually doing this. We're going to find and simplify the functions, g of minus f of x. And we're also going to find g divided by f of x. I kind of want to do all of them. I want to do the addition, subtraction, multiplication, and division because I know y'all are struggling at this point in the game, and I don't want to leave out any other options for what you could possibly understand. And I want to make sure I provide that for you. All right, so if I'm going to go with adding, so if I'm going to, and notice g is first minus f. So that's important. And same thing over here, g is divided by f, very important. It's not the same thing as this. This is a totally different beast. All right, so let's go, and they've got g's first. So I want to do something different. I'm going to choose f. So f plus g of x is what I'm going to do. So I'm going to take the function f of x, which is x minus 1, and I'm going to add the function g of x, which is x squared minus 1. All right, so we end up with, when I just clean this up, we've got x squared plus x minus 2. And so that is what f plus g of x is. I'm not factoring it because I'm not solving for anything. I'm just combining the two functions, f and g. So then we've got g minus f of x. Let's do that one. G minus f of x, function g first, and g is x squared minus 1. And then minus, please do this so you don't forget to distribute that negative, minus the function f, which is x minus 1. All right, so I'm just going to distribute my negative 1 over the binomial. You get x squared minus 1 minus x. Negative times a negative is positive 1. So we end up with x squared minus x, and then our negative 1 plus 1 is 0. So that is what g minus f of x is. I'm going to go to the multiplication of them next. So let's go with f. F times g of x. Well, you take the function f, which is x minus 1, and multiply it to g, which is x squared minus 1. So I'm just going to FOIL this. So first is x cubed, outer is negative x, inner is negative x squared, and then last is positive 1. And that's equal to x cubed minus x squared minus x plus 1. I'm just cleaning it up. So let's make this the whole thing. That's f times g of x is x cubed minus x squared minus x plus 1. That's the answer. All right, my paper's getting kind of crazy here. And then the last one I'm going to do is G minus F. I'm sorry, G divided by F of X. So G is G divided by F of X, and G is X squared minus 1, and F is X minus 1. Okay. Now I'm going to factor because I see a reason why I would need to. Over here, when I said I'm not going to factor, it's because there's nothing you can get rid of at that point. Okay. Okay, but over here, if this was a fraction anywhere, I would say reduce. We're dealing with a fraction now. So if I factor out this numerator, I know I can reduce because I know this is the difference of two squares. So I know this is X minus 1, X plus 1 over X minus 1. Okay, and which means that these two binomials will reduce, and that G divided by F of X is just X plus 1. Okay, so that's it for that example 1. But I presented all 4 of those for you so you can see. But please make sure that whoever's first or whoever's in the numerator for the function is who you are actually representing there. Otherwise, it's going to be totally wrong. All right, composition of functions. It can be written a couple different ways. There is, let's just go with each one. There is FOG, the function f of g of x. And what that means is you're going to take the function g and plug it in to the function f. I will show you. There's another one called GOF, which is g of f, function g of f, the function f, and then of x. And that can be written g of f of x. Okay. It's important to realize that they are not, okay, that this is the product of functions. FG is not the same thing. It is not. That is taking the function f and the function g and multiplying them together. Okay. Not the same thing. In this case, we're going to take, for f of g of x, we're going to take the g function, and everywhere there's an x in the f function, we're going to put the g function. This is like what we did with the difference quotient. It's the same concept. We're taking it, we're going to put it into it. Okay, so watch this. Let's go to example 2. Using the functions provided, find f of g of x and g of f of x. Determine whether the composition of the function is cumulative. All right, so the first one, we've got function f is 2x plus 1. Function g is 3 minus x. So we have to take, for this one, for f of g of x, we have to take the g of x, and everywhere there's an x, we're going to plug it in. So that's going to be 2 times, because the x is going to become 3 minus x, and then plus 1. All right. And then now we just clean it up. Distribute the 2 over the binomial. We get 6 minus 2x plus 1. 6 plus 1 is 7, so 7 minus 2x. So f of g of x is 7 minus 2x. Okay, this could also be written as f of g of x. I want to make sure you understand this is the exact same thing. These are exactly the same thing. Okay, just in case I write it differently. I'll try not to. All right, then they wanted us to find g of f of x. Okay, well, g is 3 minus x. So g of f of x is 3 minus whatever f of x is. And I'm going to put it in parentheses so I don't forget to distribute. 2x plus 1. All right. Now, because there's always an assumed 1 out here, let me shift my paper up. We're going to, whether there is or not, we need to distribute this negative over this binomial. And so we get 3 minus 2x minus 1. 3 minus 1 is 2, so 2 minus 2x. So g of f of x is 2 minus 2x. They are not cumulative because they are not the same. Okay. Oh, this is good. Please ensure that you read and understand examples 3 and 4 in the book. There is no way. Okay, I've never told you to read the book other than for the toolkit functions. I am telling you, literally read examples 3 and 4. I cannot do them justice on my own. The way they present it is amazing. And I'm not doing the amazing. It is. I'm pushing it on them because they're freaking amazing for that. They did a great job. I'm very impressed. All right. I've got more papers. Yes. All right. Let's move to example 5, using a table to evaluate a composite function. Okay, so we're going to evaluate f of g of 3. This is a puzzle. That is the best way I can describe that. This is that it's a puzzle. And whether you like puzzles or not, I'm going to kind of use that analogy for this because you have to do a treasure hunt to find out what these darn things are. And it's kind of fun. All right. So let's look at f of g of 3. And I try to tell you what I think of whenever I see these. So we've got two functions here. We've got the functions f and we got the function g. All right. If you please notice, the g of 3 is on the inside. All right. So, but the function is g of x. So that means, this is what I'm asking myself, when this letter is x, when x is equal to 3, what is g of x? That's the first question I'm asking myself for this. All right. And that's going to tell me what's going to go on the inside of this function, f. So right now I'm just dealing with the g of 3. So when x, come over here to my x column, when x is 3, what is my function g? It's 2. All right. So it's 2. So that means now I'm dealing with, if g of 3 is 2, now I'm dealing with f of 2. The question I ask myself now is when x is equal to 2, because the function is f of x. So I know I'm dealing with the x is 2 in here. When x is 2, what is f of x? All right. So when x is 2, what is my function f of x? And it is 8. So it is 8. So the final thing, f of g of 3 is equal to 8. Okay. Keep writing at a really weird angle. All right. I'm going to move to the other one. Now I'm going to do g of f of 3. I'm going to tell you exactly what I'm thinking again. Move this out of the way a little bit. All right. G of f of 3. So what I'm thinking of first is just this f of 3. That's all I'm not even dealing with the fact that they're inside of g. I'm just looking at f of 3. And the first question I'm asking myself is, when x is equal to 3, what is my function f? What is f of x? What is f of x? So I come over here to where x is 3, and I'm looking for f of x, and that is 3. So now I'm dealing with g of 3. Okay, because f of 3 is 3. So now I can bring my g into the party. And now I'm asking, when x is 3, again, when x is equal to 3, as it is here, what is g? What is g of x? So I come to 3. Here's 3. Now I have to go find my function g. It's over here, and my answer is 2. So it's 2. So g of f of 3 is equal to 2. Okay. Oh, then I provided your turn. So a good thing to do now is pause the video, attempt this on your own, and then unpause and see how I do it. Okay. I'm going to pause just so I can go to the bathroom. You're back. Okay. So my turn. Function f of g of 1. All right. Here. F of g of 1. So first question I'm going to ask myself, I'm not going to write it this time, is when x is 1, what is the function g? So when x is 1, function g is 3. So now I'm dealing with f of 3. Okay. Now I'm going to ask myself, okay, self, when x is 3, what is the function f? Okay, x is 3, function f is 3. So the final answer is f of g of 1 is 3. Okay, the next one is g of f of 4. I'm going to ask myself, okay, when x is 4, what is f? I'm working from the inside out. When x is 4, what is f? There's no other way to do this. All right, so when x is 4, f is 1. So now we're dealing with g of 1. All right, when x is 1, what is g? When x is 1, g is 3. So g of f of 4 is 3. Okay, moving on. Using the graph to evaluate a composite function. All right, we're dealing with f of g of 1. So I'm asking myself in this, when x is 1, and this is what I keep asking myself this every time, whatever that number is, when x is equal to 1, what is the inside function? What is g? Okay, so we have to look at the g function. And when x is equal to 1, what is that on the graph? Oh my goodness, this is not the best. I think it's 3. It's right about there. So that means that g of 1 is 3. And now we've got f of 3. My question here is, when x is 3, what is the function f? So I have to now look at my f function. Here is 3. What is that on my f function? Well, that's 6. So the total thing is 6. So f of g of 1 is 6. Okay. And then now it has another one that's your turn, and that is g of f of 2. So please pause the video, look at this one, and you're going to do g of f of 2. Okay. And I'm going to pause real quick so I can get my paper ready. Okay. So g of f of 2. I've got f of 2 first. So that means cats. When x is 2, what is f? All right, so we're looking at the f function now. When x is 2, what is f? So it looks like that's hitting 5. Yep, that looks a lot like 5. So now that's g of 5. And now we're going to be looking at the function g, this one over here. When x is 5, what is the function g? So 5 looks to be 3. So g of f of 2 is 3. Okay. All right. Evaluating composition of functions expressed as formulas with a numerical input. Okay, so again, we're going to be working from the inside out. In this case, we've got a 1. So given these two functions, evaluate f of h of 1. And I'm going to start from working from the inside out. So I have to look at who is my inside function. My inside function is h. All right, so I'm ignoring the f. So I'm going to be using h of x. And in this case, they're telling me that x is 1. Okay, so we're going to have h of 1 is equal to 3. And everywhere there's an x, I'm putting a 1 plus 2. So that's equal to 3 plus 2, which is 5. So h of 1 is 5. Well, what that means is I've got h of 1 is 5. So now I've got f of 5 is what I'm looking for. So now I come over here to my f function, and I'm going to plug in 5 everywhere there's a t. So f of 5 is equal to 5 squared minus 5. 5 squared is 25 minus 5, and that's just 20. Okay, so our final answer, f of h of 1 is 20. Okay. All right, let's go to the next ones. And this is your turn. So please pause the video and attempt this on your own. You can always rewind to look at the other one. And then once you're done working through it, push play and watch, see if we get the same answers. You can always fast forward. And no, I'm not going to give you the times because I don't know. Given f of t equals t squared minus t and h of x is equal to 3x plus 2, evaluate these two right here. So we're going to start with h of f of 2. Now remember, we're going to start on the inside, so I'm ignoring that h function. I'm just dealing with the f function right here, and they want me to plug a 2 in where there's a t. So I'm going to come right here and go, well, f of 2 is equal to 2 squared minus 2, which is 4 minus 2, which is 2. Great. Well, that's f of 2 is equal to 2. Well, this is f of 2. So now I've got h of 2. Because f of 2 is equal to 2, I just take that 2, shove it in here, and I've got h of 2. Now I'm going to go to my h function and follow along and make sure that everywhere there's an x, I'm going to put a 2. So 3 times 2 plus 2. 3 times 2 is 6, plus 2 is 8. So my final answer for A is h of f of 2 is equal to 8. All right, let's go to B. H of f of negative 2. So ignoring the h, we're only dealing with the inner function f, and we're going to shove a negative 2 everywhere there's a t. All right, so f of negative 2 is equal to negative 2 squared minus a negative 2, t squared. So negative 2 squared minus negative 2. All right, and that is negative 2 squared is 4. Negative times a negative is a positive 4 is 8. All right, so f of negative 2 is equal to 8. Well, I'm going to take that, plug it in for f of negative 2. So h of 8, everywhere, now I'm going to go to my h. H of 8 is equal to 3 times 8 plus 2. 3 times 8 is 24, plus 2 is 26. Final answer, h of f of negative 2 is equal to 26. Whew, this is fun. I love it, but I'm tired. All right. You know what? I don't want to do this now. I want to do this in a different video. I'm tired. I'll do this one tomorrow. I love you guys, but I'll give you the rest of this tomorrow.